Okay, so in the last class we have discussed about the DRI process in the rotary kiln, followed by the cooling process. The DRI, whatever it is emitting from the discharge end of the kiln, will be having a temperature of around 1100 degrees centigrade, and at this particular temperature, we cannot expose these uh, DRI to the ambient atmosphere for any transferring purpose, because the DRI, whatever it is coming out from the kiln at high temperatures, if it exposed to the ambient atmosphere, again there is a possibility of reoxidation may take place. There is one reason. Second thing is that high temperature you cannot transfer through any conveyor belts because the belts will get burnt off. So we need to bring down this hot DRI to the room temperature so that we can avoid reoxidation, as well as we can easily transfer this DRI from one place to another to the conveyor belts. So for that, we transfer this hot DRI from the kiln to the cooler part, that is the rotary system, where the indirect cooling will take place by supplying water jet onto the surface of the kiln. So you can see in this particular picture, this is called indirect cooling. We are transferring the hot DRI into the cooler, and this cooler also a rotating kiln, which is having a length of 35 meters approximately. And it rotates at a speed of variable speed of 0.3 to 1.2 RPM, and it is inclined almost 2.5 degrees to the. And also the residence time of the hot DRI in this particular is almost around 2 to 3 hours. And from the top, we have water sprinklers are there, and the drum is rotating, and water gets sprinkled on the drum, and that is how the heat extraction basically takes place in indirect way from the hot DRI. So the material, whatever it is cooled in this cooler drum, that is having a temperature of around 100 degrees centigrade, and that will be now at this stage we can easily carry this DRI and transport to the storage yard and all through the conveyor belts. Whatever the cold DRI which comes from the cooler, that will be discharged from the rotary kiln site to the area that is called as product separation area. There, the DRI is separated from the coal ash as well as tar, and by using magnetic separators, and then it is screened to various size fractions. So the product, whatever we are getting out of this cooler, will be of cold DRI. Along with that, a certain amount of coal ash as well as tar will be there. That is the entire mixture you have. So if you want to collect the cold DRI, so we need to separate this tar as well as coal ash from the DRI. So for that, we basically use a magnetic separator. So DRI is having magnetic property, so it will stick to that tar. And the rest of the parts, coal ash and the carbon doesn't have magnetic properties, so it will get separated. So this coal DRI, again, we will be having different size fractions. So it depends upon the kind of the applications. So we basically uh, do the size fraction by using screens. So at the, if you see the other end of the kiln where there is a feed end, you have a dust settling chamber will be there because a lot of dust will be emitting out during this process, and apart from that, a certain amount of waste gases also will be coming out, and these waste, just like the glass furnace process, the off gases, because a certain amount of dust will be there, along with a certain amount of heat associated with that gas, which is having good calorific value. So these heat, if you want to reutilize it at different parts in the plant, then first and foremost thing what we need to do is that we need to do the separation of this gas from the dust. So that is basically done in the dust settling chamber, where the dust plus gas both will be entering into this chamber at a temperature of around approximately 850 degrees centigrade. And because of this direction at which these gas are flowing, we are allowing this gas to flow in the upward direction, just like the concept what we use in the catchers in the blast furnace process. Same thing here also, where we allow this gases to flow in the upward direction, because of which the velocity of this dust will be equal to 0, and dust will falls down and settle at the dust settling down. And like that, whatever the dust you can see in this particular picture. Yeah, this is the feed end and of the kiln, and then you can see the dust settling chamber. This is the dust settling chamber, and you have ABC. There is after burning chamber is there, and then you have um, um, evaporating cooler, and then you have electric precipitator, and then finally it goes to chimney. So whatever the gases which is clean in the settling chamber, that gases will pass into the ABC, that is after burning chamber, where a small amount of because these gases will consist of CO and CO2. So it is environmental friendly if you release CO2 into the ambient atmosphere rather than some of CO. So if at all any carbon monoxide which is unconverted into CO, that will be basically burnt in the ABC by passing a small amount of oxygen through a small inlet, where the unburnt carbon and as well as CO will be combusted and form CO2. Because you know very well that CO gas is greenhouse gas, where we cannot release that into ambient atmosphere, not good for that. So this is what we do basically in the ABC, that is the unburned carbon and as well as carbon monoxide, whatever it is, that will be combusted in the after burning chamber before you submit for the further processing. From ABC, then the gases will enter into the superheater, that is the waste heat recovery boiler. WHRB we call it as a waste heat recovery boiler. That means you have a boiler tubes will be there, water circulating boiler tubes, where um, where this gas, whatever it is there, the clean gas, whatever it is there, waste gas, that will be allowed to fall onto these boiler tubes, and water circulating boiler tubes will convert the water into the steam because of the heat transfer concept. The heat which is associated with these waste gases will be absorbed by the water which is circulating in these tubes, and then the water will come into steam, and that steam is used for the power generations using turbines. So from this WHRC, that is a waste heat recovery boiler, the gas enters into the then ESP, where the fine dust particles will get separated. The temperature of the gas will be reduced at this stage to 190 degrees centigrade, and then this heat is sent to the ambient atmosphere through the chimney. So after the heat which is allowed to fall onto this waste heat recovery boilers, the temperature of the waste gas will be reduced from 900 to around 200 degrees centigrade, and then the leftover waste gas, whatever it is, that will send it to the ambient atmosphere. So here there will be an ID fan will be there. That's induced draft fan, which basically sucks this gas. So it is the same process which we see even in the central process centering house and all, where the suction of the air basically takes place through this ID fan, which are present somewhere away from this system. And from there onwards, what the movement of these gases in this particular direction is basically controlled by these ID fans. So there's a high capacity induced draft fans will be there. So those fans will basically do the suction. Because of the suction only, this air will pass like this through this particular process, and then it goes out. Okay. And then see the sampling process. So in a nutshell, if you see whatever we have discussed till now, in a nutshell, if you see, that means yeah, here you can here you have the burner. Here you have the your burner is there, and then the air inlet is there. So you have ID fans here. So from here, it is these ID fans will try to suck this entire air from this kiln. Then it pass through like this. It pass through like this. So this is the cooler. This is the cooler part. This is the feed end, and this is the discharge end of your product. And at the discharge end, you have an inclined system is there, where through this inclined plate, your raw material transfers into the rotary kiln to the cooler. Okay. And then at the cooler end, you'll have another discharge will be there, where the cold DRI will be traveled, will be collected on the conveyor belt. And the other end of this kiln, if you see the feed end side, if you see here, actually we have a feed pipe blower. This feed pipe blower, the function is, as I already mentioned, that it will compress this air. This air, whatever it is traveling in this direction, it has to pass like this in the straight form, rather than it is going outside like this. So to avoid this air, hot air, to travel in this direction, we are compressing here, so that instead of going in this direction, it will move in this direction. So the feed pipe blower is a function of feed pipe blower is to provide some pressure here, so that the waste heat will not travel in this direction, comes out, rather than it is moves into the settling chamber as well as air. Okay. So in the dust settling chamber, as this is just like you see, it is just like the functioning of the scrubber. We are providing the direction of the waste gas to travel in this direction, in the upward direction. So when it is going upward direction, the velocity will be equal to 0. Dust particles, so dust particles is falls down. And now the clean gas will travel into the ABC. At ABC, it is after burning chamber. There is a small inlet will be there where unburned carbon or carbon monoxide, whatever it is there, that will be combusted here, and the temperature will be certain rises, and then the waste heat, whatever it is there, that will enter into the after ABC, that will enter into your waste heat recovery boilers, where that will be the heat associated with that waste gas will be maximum utilized in converting the water into steam, and that steam is basically used for the power generation. and after whatever the heat which is extracted out from these waste gases, the leftover leftover heat, the 200 degrees centigrade, whatever it is, that will be simply sent out to the ambient atmosphere through the chimney. Okay, so this is what we are seeing. Now, coming to the sample collection. So, as the process is going on inside the kiln, so whether this production process happening uniformly inside the kiln or not, whether the reduction process happening uniformly from the surface to the core of your pellets or not, that will be basically studied by collecting some random samples at different point of time during these DRI process, and the sample collection basically done from these holes. So throughout the kiln, there will be some holes will be there, which are closed with glass wool, and while collecting these samples, basically they use some rod, and they just simply poke these rods into this hole, and then so that some sample will be fallen down from these holes, and then that fall down sample, whatever it is there, that will be taken to the laboratory, and then they will do they will take that sample into two halves, and then they see the color of the structured surface. So based upon the color of the structured surface, we can come to one conclusion that the reduction process happening properly or not. Okay. That I will show you in the further slides how the sample looks like. And also, apart from this particular sample collection hole, you can also see there's thermocouples which are inserted at different locations across the length of the kiln. So the kiln temperatures are measured with fixed thermocouples, and there is also a quick response thermocouple, that is QRT ports also will be there. So this K type of thermocouple, basically whatever we use it, they are fixed at different locations to study a thermal profile of the kiln. Sometimes this whenever there is an accretion formation is happened inside in huge quantity or something like that, in that case these thermocouples may not able to give proper reading, proper temperatures which are present inside the kiln. In such cases, this QRT, that is quick response thermocouples, are used to collect the temperature profile of the kiln. Okay. So, as I said, that we basically collect the samples from this sample collecting holes, and you can see these are the samples which are collected, and they just try to break into the pieces. And now we can see these are the fractured surface of the DRI. So you can see different colors from the surface towards the center. So if the color inside the pellet is yellow in color, like something like this, that means it is reduced properly. If the color inside the pellet is bluish color, it is partially reduced. And if it is if the color inside the pellet is black in color, then it is not at all reduced. So this is how we can basically identify the reduction behavior of the pellets inside the kiln. Then come to the other topic, that is coal dryer. Sometimes what happens, especially in the rainy season and all, the raw material, whatever it is stored in the stock plant. So these raw materials, basically, they get wet, and when you charge such kind of raw material, certainly it takes a lot of time to ignite and all. So before you subject this kind of wet raw material into the kiln, so we basically do the drying of this raw material, and then the dried raw material will be allowed to charge into the. So for drying purpose, we use cold dryers. Basically, they are similar to that of this kiln, but of different dimensions. And these cold dryers are basically long cylindrical drums which rotates on a horizontal axis, connected with a hot air generator, or can also called as a heating chamber. And this hot air generator is used in this in a cold dryer is a device basically that produces steam of hot air or gases. It is basically directed into the cold dryer to facilitate for drying. We basically use light diesel oil to ignite, and then after attaining certain temperatures, roughly around 250 degrees centigrade, flue gases like the BF of the blast furnace gases will supply, and then at that time this light diesel oil supply will be stopped. But only this LDO, the light diesel oil, will be used as a for burning purpose at the starting stage. But once you reach the required temperatures, then this LDO supplies will be stopped, and alternatively BF gas will be sent. So this basically again similarly just like a rotary kiln, your feed end and your discharge end will be there. So the coal is fed into the dryer at feed end and travels to the drum, and as it rotates, this drum also rotates at an RPM of 4.3 approximately, and the length of the kiln will be approximately 21 meters, and it can discharge almost 70 tons of dried coal per hour. And we also sent the hot air to dry, which dries the coal, and that dried coal will be sent in, discharged out the kiln. So some of the silent features of the rotary kiln process, if you see, there is a flexibility with regards to the type of iron bearing material, whatever we are using. Could be for the production of DRI. It could be lump, it could be pellets, it could be any iron bearing waste which is associated with in the plant. And you can also use a wide range of solid fuels ranging from anthracite to lignite, because here main purpose of or main objective of using this route of iron making is that we no need to go with coking coals, the production of DRI. We can produce DRI with the non-coking coal, which are abundantly present in the country. So that is the great flexibility we have. And also in that way, the cost of the raw materials also will be reduced. Then waste gas conditioning by controlled post-combustion. That means depending on the fuel value required for power generation, post-combustion the kiln will be controlled. And various strengths of this coal-based rotary kiln DRI process, you see, efficient mixing of solid charge during simultaneous heating and reduction. So this is what actually happens within the kiln. And the kiln rotation renews the solid charge of furnace atmosphere, enhancing the heat and mass transfer to take place effectively and efficiently. But some of the problem is one of the problem is that the efficiency of this kiln, because here the amount of the working volume is used for or the volume of the or you can say the volume of the kiln which is occupied by the solid charge is very less. It's hardly less than 15%. So there is a huge empty space is there, and that means there is a larger free board is there above the solid charge, so that the reduction reactions can take place effectively, okay, in the free board space. And if you see the energy balance in the rotary kilns, the major input energy to rotary kilns is through the coal, and recirculating heat counter for around 0.1 gigacalories per ton of iron produced. Only 35% of the output energy is associated with sponge iron, and around 40% of the output energy passes through the waste gas. Therefore, waste gas contains a significantly chemical heat. Significant amount of chemical heat is there in the form of CO, which could be burned for heat generation, for rising steam and power generation. That is what we are doing even in the ABC. So typically, 1 lakh TPA rotary kiln produces. That is 1 lakh ton per annum rotary kiln. That is the capacity of rotary kiln. Basically produces around 80,000 meter cube waste gas at a and at a temperature of 1000 degrees centigrade. And if you use this volume of waste gas at this temperature, and certainly we can produce an electricity of around 7.5 megawatt. And for 1,50,000 ton per annum kiln, if you see, then the power generation could be 10 megawatt, and 70% of it will be surplus after meeting the power requirements of the plant. So you can produce surplus amount of electricity which are required for the utilization within the plant. This is one of the advantage that you can sell it out there. And the drawbacks of the rotary kiln process is that productivity, as I said, that you have a large freeboard is there, and very less volume of the kiln is utilized for this charge to be rotated inside the kiln. So the productivity is very low compared to that of other kilns or other furnaces. So maximum it may go to some 300 ton or 500 ton capacity per day. That is the capacity of one particular kiln. And due to rotation of 0.4 to 0.5 of this particular reactor, instrumentation of the reactor for process control becomes very difficult. Most importantly, the waste gas has to be cleaned before it could be disposed to atmosphere. So the waste gas contains a lot of toxic gases. So that we should take into consideration. Apart from that, the solid accretions which are formed inside the kiln. So that is the DRI accretions. So the reason for the formation of these accretions are basically utilization of the low actuation temperature of the coals. The coals which are having low actuation temperature, if there is such kind of coal, then certainly solid accretion basically takes place. So this will also occupy a certain amount of volume and manage the working condition of the rotary kiln. So the principal reason for accretion formation of rotary kiln is due to formation of low melting complex compounds of FeO, SiO2, Al2, kind of system. And these compounds having low temperatures, and because of which it gets fused. So these complex compounds decrease the fusion temperature of the kiln charge, which in turn adheres to the refractory walls. So as the ring grows thicker and thicker, certainly the working volume of the kiln will be reduced. That will certainly show an impact on the productivity of the kiln. And these rings which are formed are basically located at the reduction zone of the kiln. Okay, so again, this creates a problem. So basically, to remove these accretions inside the kiln, the broke machine is a remote controlled robot. That is what we basically use it to safely and effectively remove the accretions. So sometimes manually also they do it. Otherwise, usually most of the cases, this robot machine which is used for the building purpose to remove these accretions inside the kiln. And there is another concept called hot spot. That means if the kiln refractory layer breaks due to any sort of thermal shocks or due to erosion, then the outer steel shell directly comes in contact with internal heat of the kiln and becomes red hot. This is known as hot spot in the kiln. Okay. This is one of the defects, you can say, in the DRI process. So we can stop it here, and this is the end of the DRI process to rotary kiln.